Stanford University.
Welcome to the seminar on People, Computers, and Design. I'm Terry Winograd. Quick announcement. Next week's speaker will be Dave Karger from MIT. And if you read his title carefully, you'll see it's something about how to get people to use better information, not how to manage information better. And he's saying that rather than sort of assuming as a fixed given the information people have available and then trying to make them better managers of it, how do you step back and take a look at what the kind of data they enter, the kind of data they use. So he's part of an interesting group there at MIT. Should be interesting to hear him. This week we have two speakers, Jeff Johnson and Austin Henderson. And the title you see up there, Conceptual Models, is also the title of the book they've recently written, which you can find on the web easily. And they'll be talking about that current work, but I can't resist the temptation for a little memory lane. I have known both of them for well beyond 30 years, primarily and starting out at Xerox. So those of you know the legend of Xerox PARC, the early GUI, the whole development of what we now think of as computer interfaces. There's the first commercial version of that, the Xerox Star. The paper which I assign on the Xerox Star was first authored by Jeff. It was written by a bunch of people. He was one of the team that actually developed the stuff that we all now use. So he's been doing graphic interface development for many, many years at a number of places, including Xerox and Sun, and he's a consultant. Austin was at Xerox PARC in those early days, and what he's responsible for is not the graphical interface you use as much as the copier interface you use. He was on a team that was looking at, in those days, I know, we did have Xeroxes in those days. They had come into existence. But basically, the controls that ran it were the ones that were directly connected to the things they controlled. You push this button, it turned on something. You push that button, it reversed the paper, whatever it was. And he was one of the team that first said, why don't we go virtual on this? Why don't we have a control screen where you do what makes sense to you as a user, and it'll figure out which buttons to push, right? Which mechanical buttons. So it was really moving from the sort of simple notion of controlling the object to the notion of controlling the job as you want it. And did a lot of pioneering work in that, expert systems for designing systems, and so on. Has been a number of places as well since then, including Pitney Bowes, which is an interesting, most of us not highly visible here on the West Coast. And has been interested for a number of years, his own Rivendell's your consulting firm, right? A consulting firm called Rivendell, but looking at making computing more natural, more plastic. So, without further intro, one more, sorry, I can't resist. How many of you have ever noticed on the third floor as you walk out of the elevator an exhibit about a early personal computer company called Chromemco? Okay, next time look closely. It's got Jeff's ID card. He was a student here in psychology and was part of the original Chromemco team.
Okay, thank you for that spotted introduction. Okay, so this is the agenda for our talk, and we have a lot of material to cover and a limited time, so I'll try to be quick. So we're going to give you some background. I'm going to give you some background. Austin is going to sort of frame the problem. Then we're going to both talk about conceptual models. I'll talk about the basics of conceptual models. Austin will cover some advanced concepts. And then at the end, I'll come in and talk about the benefits of developing and designing conceptual models. So the history of this is that, or the history of our interest in this topic is that back when we were both working at Xerox, we were exposed to the notion of conceptual models because the people who designed Xerox Star did something unusual, which is they designed the software and then they built the platform on which the software ran, the operating system, and then they designed the computer that would run the operating system on which the software and the application would run. So it was done in a very opposite direction from the way most software's applications are developed these days. And in the process, they developed what we called conceptual models, which is an understanding of the objects and actions that people would manipulate when they were using the software. So that was the Xerox PARC days. Then I wrote some books in the year of the 2000 years, one called GUI Bloopers. The second edition of it is called GUI Bloopers 2.0. And I talked about conceptual models in that book because I had become a religious convert. I'd come to believe that conceptual models, developing conceptual models when you build an application, is really crucial to making sure that your application actually helps people perform tasks. And then I also talked about conceptual models in my book, Designing with the Mind in Mind. And Austin and I wrote an article that came out in the Interactions magazine in 2002 called Conceptual Models Begin by Designing What to Design. And ever since then, I've been giving tutorials at CHI on conceptual models. And in fact, I'm giving a tutorial on conceptual models. Austin and I are both giving separate tutorials on conceptual models at CHI this year. So finally, the culmination of all of that is that we wrote this book. We decided we had so much to say about this, and we thought about it so much that we wanted to put in a book, so we wrote this book. Now, it's a thin book, and there's still a lot more to say, and we're probably going to have to write a second edition of this book at some point. But so I just wanted to give you a brief idea of the history of how we got here to the point of having this book.
This is just to sort of set the stage to make sure that we are aligned on what things we are talking about. The idea of a person using an application of some sort, we tend to use the word application as a generic for copiers, for anything, some tool that they're using, is thinking about some work that they're trying to get done. They're working in a domain, and there's some task within that domain that they're trying to get done, and they think that this application will help them get that work done, and so that they're putting together crudely a plan which sort of says, if I do these things together with some stuff over there, then which is not done on this device, then I'll be able to get the job done. The thinking is around the functionality, but the actual picture of what they are going to see is the user interface. So what we want to do is, that's all right. Yeah, won't see it. No, that's exactly right. I'll just talk. Okay, all right. So, too hard. This is the very crude picture of what it is that we see people trying to do, and it's that functionality that the user is trying to put into a plan to get the job done. Now, in anticipating that you're going to build that application, your question is, what should the functionality be? Now, very often we start saying, well, what should it look like, and what should the user interface be? And our pitch is, don't start there. Start with the functionality that is going to be part of what the user is thinking about. As the designer, your problem is to see all that. You as a designer are imagining what the user's domain is, what the tasks are going to be, and then you're putting together your picture of what that function should be. And that's the conceptual model that we're talking about today. We're talking about the picture in the mind of the designer who is trying to think about what this application should be to support the task. And that picture is an idealized view, because any real user is going to have a mental model which is maybe like this or maybe not, you don't know. But the idealized view of what it is that the user is going to think, and the way they're going to be able to build the plans is what the designer needs to address. Our pitch beyond this is that having a conceptual model at the center of the practice of building applications keeps everybody aligned, because everybody needs to know what that is. And so we've sort of drawn the usual cycle, understanding the user needs, putting together a conceptual model, and then doing the conceptual design, which is the design of that model, then the UI design, then some implementation, releasing it, and throughout all of this, these various different forces are all pushing on that conceptual model. When you get there and you say, we don't have enough memory to do that, whoops, you're going to have to change something. That means if you just do it when you're doing the implementing, you may throw the whole thing off. So the idea is have the conceptual model as the place where everybody has to come together to fight out what the functionality of the thing is going to be.
Okay, so I'm just going to go through some basics about conceptual models for you. So you can think of it this way. You can think of a user interface as having concepts and presentation. And the argument that we're making is that the concepts of an application affect the architecture. They affect how you build the application, and they affect also how it looks and how it works from in the user's mind, how the users model the application in a way that allows them to predict how it will behave. So our pitch is that you should consider a user interfaces or an application's concepts first, and then its presentation, not the other way around. And the reason we do this is it's a sort of a reaction against what we see in the industry, which is where people immediately start drawing screens. Or if I go into a company as a consultant, the first thing they'll say is, can you give us some wireframes for what this is going to look like? And I'll say, wait a minute, it's not on? No, it fell down. Okay, sorry. They'll say, can you give us some wireframes for what it's going to look like? And I'll say, well, do we know yet what it's supposed to do? And they'll say, well, we'll figure that out. Well, okay, so basically, first design what the application is, and then design what it looks like and how our users operate it. Don't jump right into GUI design. So a conceptual model it's the organization and structure of the user interface. It's the objects, the conceptual objects that people manipulate. It's the actions that people take when they're using the application. And when I say actions, I don't mean keystroke level actions like clicking mice. I mean like opening bank accounts or actions at the conceptual level. The conceptual model, and then if you as a designer create a conceptual model, what you're essentially doing is you're creating the model that you want users to build in their mind of the application. And if you don't build a conceptual model, they will build a model in their mind anyway. It will just be sort of random. So it's better to develop a conceptual model and sort of then embody it in the application. Now, over the years of experience in doing this, we've learned that the goals for conceptual models are make it simple. Make it as simple as you possibly can, and make it focused on the task domain. Focus it on the task domain. If that task domain is about bank accounts, then focus it on that. And then it turns out you can get user feedback and revise your conceptual model before you've actually written any code, or even before you've even designed any screens. There are ways to do that. So a big part of building a conceptual model is doing what we call objects and actions analysis. And these words comes directly out of what we learned from Xerox, our work at Xerox a long time ago. They use the same term, object actions analysis. In our book, we actually called it object operations analysis because there was a conflict with some other possible meanings of the word objects and actions. So we call it objects operations. But for now, it's the objects, the user-exposed conceptual objects that a person will see, not necessarily literally see, but will encounter in an application. And what is the relationship between the objects? Like, there are some standard relationships that come up over and over again, like what objects are a subtype of what? Like, for example, a checking account is a kind of bank account. Okay? And what is a part of what? Like, for example, a muffler is a part of a car. What can contain what? A folder can contain files. Okay? So those are the kind of relationships that come up over and over again in models. And then what are the actions on each object type, and what are the attributes of each object type? Now, this is all very abstract, so let's look at an example. I talked about bank accounts, so let's talk about managing a bank account. The objects in a bank account application, in the conceptual model for a bank account application, would be something like customers, accounts, debit cards, and checks. The objects would not be concepts like databases, dialog box, modes, and strings, because databases, dialog boxes, modes, and strings are concepts in the domain of operating a computer. They are not objects in the domain of working with the bank account. Yes?
So I think that you are fundamentally and deeply right in your conceptual model's viewpoint on design. I think that high-level design is done far too little. And let's see. I think that, but I've been. When somebody walks out of here today, I hope they're persuaded by something. And I don't think this example is necessarily persuasive, because I have never seen a bank account system that didn't have customers, accounts, debit cards, and checks. Like, that's not where the absence of those is not a problem. Something else is the problem.
The problem is the presence of things like dialog boxes, databases, and modes and strings.
So what exactly makes those the problem? Because most user interfaces, even good ones, have databases, dialog boxes. I'm playing Socratic here because I think if we have a smoking gun, it's easier to buy than medicine.
Right. Well, the problem is that, for example, when I go to my bank account, when I go to my online banking system and do banking operations, there's a database in there, but I don't have to know that there's a database in there. It's irrelevant to what I'm doing as a user, that it happens to be storing things in a database. It could also be storing things in some other way.
So how does that manifest concretely in terms of a suboptimal user experience?
Well, I'll give you some examples later. I actually have some examples later in my presentation. So let me just say, in terms of objects, we definitely don't want things like databases, dialog boxes, and modes, and strings, but we might want things like templates and command sequences, even though people who had not ever used, before the bank accounts were computerized, there wasn't any such thing as a template. So you could think, for example, well, maybe I'm going to make the same, I'm going to do the same bank transaction every month. And so maybe I have to create an object, the conceptual object that users are aware of, called a transaction template, so that users can actually fill it out and sort of make a payment to their utilities every month. But what I said, the reason I put the word maybe there is that I said earlier, simple is better. Okay? And so it's much simpler if you can figure out a way to implement the functionality of repeated transactions without introducing the concept of a template and making that an exposed template that people have to, an exposed concept that people have to be aware of in order to use your application. Okay, and command sequence is another one. Suppose I come in every morning and every morning I do the same 10 things, and I just want to teach my banking application that every morning when I come in and sign in, it should do those 10 things automatically. Well, you could do that if you were a geek by programming in this macro system that allowed people to set up all these macros, and then they could do whatever they wanted to do when they came in the morning. The trouble is, my grandmother is not going to deal with that. Okay, so you have to, if you really want to get action sequences in there, the way you have to do it is some other way that doesn't involve exposing the notion of command sequences or macros. Okay, let's move on.
When you talked about template, in some way you have introduced a new concept into the domain,
Yes.
which is banking. So while we are on it, can we, although you said that it's a maybe, but how about taking existing concepts within the domain and in some sense transforming them to make them simpler? If a particular transaction was done in 5 steps and while you are modeling it or writing it down or thinking about it, you figure out that it could actually be done in 3 more simpler steps. So is it a good thing that you actually go on and change concepts that already exist within the domain?
It might be a good thing and it might not. I mean, you might get user resistance if you change it. We can come back and talk about that a little bit more later. When you're building a computer system for a particular task domain, you're always going to be changing the domain. You're changing the domain by adding your application. The question is how much you're changing it and how much resistance you're going to get from your users if you try to change it too much. And also whether your users are captive in the sense that it's part of their job to learn the new way, or whether they are consumers who can just buy somebody else's product that they like better. Okay, so now let's talk about actions. We talked about objects. So a banking account program would have actions like depositing and withdrawing funds, opening and closing accounts, viewing and reconciling accounts. The actions on checks would be things like writing, voiding, depositing, and cashing. I guess I must be dating myself by putting this out because no one writes checks anymore unless they're old. Debit cards, changing a PIN would be an action. Actions like clicking buttons, loading databases, editing table rows, creating records, and flushing buffers are not actions in the domain of operating or of working with a bank account program. Those are actions, again, in the domain of operating a computer, so they shouldn't be in. And again, maybe you need operations like create template and save command sequence, and maybe you don't. Maybe you can get away without having those. It's better if you can get away without having them. And then attributes. Well, a check. What will a check have? A check would have a number, a date, a memo, an amount. An account would have an owner, a balance, an interest rate, a date opened, a currency. A transaction might have an amount, a date, and a description. But you wouldn't want your system to expose the fact that a transaction has a memory size or an export encoding. Because again, those don't have anything to do with managing the task domain of managing bank accounts.
Yeah, this raises for me a question which is context. That is, export encoding, in fact, I care a lot. I use Quicken, and I want to know when I can put something into my spreadsheet to do more with it.
Right.
So export encoding actually is an exposed concept, which is critical not for working in that app, but for interfacing it with the rest of the world.
Right, right. And so one of the things that you can do if you have to if you have to add a concept that is only used in very certain tasks, and specifically if it's used in tasks that involve interfacing your application with other applications or with the rest of the world, is you can basically restrict its not only its the areas where the user has to use about it, but even which users have to know about it. So there are many IT applications out there for managing enterprise IT in which these users get to see these objects and actions, and these other users get to see more objects and actions because they're more maintenance users. But as much as you can, you want to focus in on the task domain. Now, again, the task domain may be variable in that you may have your task may be to export this file from your spreadsheet to your bank account program.
So another example of that is I was on the train this morning and I wanted to download a file and I'm online over my cellular connection and it showed me that it was like a 20 megabit file, and I said I'm going to wait to download that until I get into the office. And so kind of like Terry pointed out, that there are some times that export encoding matters for the user. There are some times that file size or memory size matters for the user.
Right, in 100 years from now, it won't matter. That will be an irrelevant distinction.
Some other system characteristic will.
Right.
As much as I believe the dream that you want to hide these as much as possible.
Right.
But as Terry pointed out, you can never hide them completely.
Right, but what Austin and I think are arguing against is what we see often and over again in companies is the following thing. You're in a design meeting, and the people in the room are going, okay, but what if the users want to do this? Oh, but what if the users want to do that? What if the users want to do that? And they add all of these concepts in to cover all those, what if the users want to? And all the people in the room are geeks. They're all computer programmers or engineers, and so they're all designing from their point of view, and they essentially build, instead of building an application for doing a task, they build a toolkit for building applications for doing a task. And that's not what the users want.
So they almost would argue more for a persona-oriented design or a more task-centered design, which is subtly different than a conceptual model design.
Yes. Right. I wouldn't necessarily, I mean, I think making something extremely task-focused is a conceptual model design. That is, you can use conceptual models to make something very task-focused. So how are we doing in time?
So the only thing that I would say to that one is putting that the plan between the task and the conceptual model. To the extent that the plans can be very simple, that's great. But leave the space for those other things. So if I've got a copier which won't make two-sided copies, well, I can do things by hand, right? But you put together the plan, so.
Yeah, and you can actually put on the cover of the copier what the steps are that somebody would use if your copier did not have built into it the sort of notion of two-sided copying. Then you could tell people what this procedure is. Okay, so when you're building a conceptual model, essentially, simplicity is one of the goals, and one way to achieve simplicity is by what I call extreme consistency. So when you have a conceptual model built and you develop these objects, actions, attributes, what you get is a vocabulary. So vocabulary comes out of it because the objects will have names, the actions will have names, the attributes will have names. And you can decide within your development team whether those names are going to be actually exposed to users in the documentation, in the application, and that sort of thing. But once you make that decision, once you make the decision to expose this term to users, you must make the decision that you will use that term and that term only for that concept, and never any other term for that concept, and never that concept with any other term. So terms must be mapped one-to-one onto concepts. This is very important. I see all the time in the industry the error, and I'll show you the error in a second. But the rule, the design rule, which actually phrased extremely well by a colleague of mine named Carolyn Jarrett, which is same word, same thing, different word, different thing. Okay? And so you need to have somebody in your team, namely tech writers, who protect that vocabulary. I'm going to go quickly over this, but basically one of the other things that you get when you develop the conceptual model is you can start building what are called conceptual scenarios. Stories of users doing the tasks with your conceptual model. Another term for these conceptual scenarios is essential use cases. And these are expressed at the conceptual level. John comes home from work, he gets out his photo program, and he decides that he's going to sort his photos. He takes the first photo and moves it to the last position, and then he decides that all of the pictures that are at the end, he actually wants at the beginning, so he grabs them and moves them to the beginning of the presentation, and then he's satisfied with the presentation, and he closes the application. I haven't said anything about slides, sliders, dialog boxes, modes, strings, buttons, radio buttons, or anything like that, okay? But I have expressed what the software can do. All right. So here's some examples of bloopers that people make at the conceptual level. One is that they expose non-task relevant concepts. How am I doing time? Okay. They expose non-task relevant concepts, so exposing the implementation needlessly. That's one example. I'll show you some specific examples of that in a minute. Another is confusable concepts. Like, for example, on a Macintosh, I don't know if you've noticed on many Macintoshes, there's two separate yellow sticky note apps. Okay, there's one that's in what's called the dashboard. There's a dashboard that pops up and you can put it away, and there's a yellow sticky note app in there. And there's also yellow sticky notes that can appear on your desktop. And you know, I know that I'm a geek, so I know that there's those two different apps. But my wife, for example, she said, I put something in a yellow sticky note and I can't find it. I said, well, which yellow sticky notes did you put it on? She said, I don't know. What are you talking about? There's yellow sticky notes. Those are two different concepts in the Mac, and people can't tell them apart because they're very confusable with each other. So confusable concepts is a common blooper. And then non-task relevant terminology is another common blooper. Like, for example, at one company that I won't name that builds databases that's very large here in the Bay Area, when I consult at that company and I do work for them, at the end of my consulting period, I have to go online and record the hours that I've worked for them. And the command for doing that, entering the hours that I worked for them, is create new record. Why? Because they're a database company. There's a database here. So I have to create a database record if I'm going to put some new information into the system, obviously. And then we have ambiguous terminology. Different terms for the same concept and the same terms for different concepts. I'll show you an example of each of those. But first, let's look at this blooper, which is exposing the implementation. At one company where I was doing consulting, there were stock analysts who were creating transactions. People would call them, say, buy 500 shares of BMW for me, so they would create a transaction. If they knew that BMW was doing something interesting and so people were going to be doing a lot of the same transaction, what these stock analysts could do, because they could create a template for a transaction to make it easy to make a very similar transaction many times in the same day or in the same week. And there were two kinds of templates. There were templates that you would create for yourself, your own personal use, and there were templates that you would create for your entire work team, your entire work group. And they were called, the commands for creating those were called create database template and create local template. Why? Because the ones that you created for sharing with your colleagues were created in a database server, and the ones that you created for your own personal use were on your own computer. Okay, but I told them they should be called create shared template and create private template in order to avoid exposing the fact that the implementation of how it was implemented. Let's talk about different terms for the same concept. Here at citycarshare.org, here's an error message. The username and password you entered do not match. Member ID, password. Okay, so basically somehow they got a disconnect between the member ID. Maybe member ID was once called the username and then it got changed and they forgot to change the error message. Maybe the error message is being generated automatically by software that's looking at the name of the control, the text control, the text field. There are a lot of different reasons why this could have come about, but it is a blooper. And here's the opposite blooper, same term for different concepts. In WordPress, you can go to your dashboard. And inside the dashboard, one of the pages in the dashboard is called the dashboard. So there's this thing called the dashboard, and inside it is something called the dashboard. Now, you can imagine that makes it hard to talk about, right? So that's the same term for different concepts, and that really screws people up. Next.
So what I want to do now is look at all of the, I mean, Jeff's just sort of laid out, here's the structure, you know what we're trying to do. What we wanted to do is then we took these ideas and we sort of looked at the kinds of problems that emerge that you have to deal with. And much of the book is just walking through these different kinds of problems. I want to give you a view of those and then take a look at a couple of them. So these are the main areas. Let's take a look at object operations analysis, Jeff has talked through a number of these already. What are the operations? How do you decide when things are similar or different? Again, you have to look at the task to determine those issues. The question of whether or not you're going to have a generic object of which everything is specialized, or whether you're going to have different objects where you don't recognize the similarity between those. These are just the kind of work that you need to do to sort out what the conceptual model to be. And it's not like there is a unique conceptual model that is going to emerge. What one has to do is make some decisions and figure out ones which will give, over the class of all of the tasks that your users are, and you're anticipating your users will do, the best way, the simplest way to get to those plans we talked about. Mention a couple others. The containment relationships. Do you or do you not need to do the distinguishing of those? In addition to getting that basic model, there's a whole collection of concerns that you have in building a conceptual model about the learning that's going to have to go on, that the user is going to have to actually be able to, how are they going to come to that conceptual model? And that needs to be built into your thinking about it as well. So obviously metaphors have played a very important role in past, where there's a well-known set of concepts that you believe that your users will be able to map into the space. And when you do that, some of those things should go and some of those shouldn't. So how do you find out which one, how do you signal which ones of those are getting carried in? The issue of, as you talked about earlier, the idea that you have for most things, and we did it all the time at Xerox with the simple copier, and then you could flip up the cover, and suddenly you see all those other things it can do. You have these two different models, and you hope that if you do that, that those two models map well to one another, that one is seen as extending it rather than changing those models. So progressive disclosure is something that is a device for keeping the model simple for simple things. The issue of what's simple and for whom becomes the issue. Component models, building different parts that can work quite separately and independently of each other. So all of these kinds of techniques and problems that users are going to have, you should be thinking about those as you're building the conceptual model. A third area is the distinction that we've drawn between conceptual model and the user interface. And Jeff's quite compellingly, I think, said, don't get the user interface into the discussion. But this gets a little tricky. And so it's easy to say, well, if you can see it, if you can touch it, then it's part of the user interface. But if you're, as I was doing working for Pitney Bowes, dealing with people with an application whose subject matter is itself graphical. So for instance, at Pitney Bowes, it was about maps. The objects in the map are things that you can touch and feel, but they are the concepts of the program. So it's sometimes a tad difficult to get clear in your head which is the conceptual model and which is in the user interface. Again, just an alert, and we sort of talked through some of the problems with respect to that. The issue of interactive concepts, ones which are such as templates and that which you are going to be building, are things which you may have to actually deal with interacting with them. And so you will need to, again, confront the distinction between the conceptual model of a thing which is interactive, which you deal with, and the user interface for dealing with it. A fourth area, just the identity of objects. When are things the same object? When are they the different objects? Jeff's talked about containment, the issue of synchronizing objects. if in fact things can shift independently. When is it the same object? How do you deal with that? What is the notion of sameness? More and more as we deal with real-time interfaces, we're seeing the struggle to keep that object clearly as the same object as that one, and how do we deliver that?
And I'll just comment that one of the things that I've observed is that outside of computer science expertise, people who don't have computer science expertise have a big problem with something that we find easy, which is for us the distinction between two objects being linked, or a situation where you're looking at two manifestations of the same object versus looking at two different distinct objects. That for us is a concept that we're used to, but for lay people it's not. Okay, and so it's important for an application to make it very clear to people whether they're dealing with copies or they're dealing with connected, linked things.
And so then there are some advanced concepts which are, on the one hand, going meta. That is, despite what we've just said about the user interface being off limits, in fact, if you start doing things like undo and sequences of actions, you begin to treat the objects of your interaction as concepts in the program. Again, we're not necessarily talking about the user interface for undo, but we are talking about the activity of operating using the conceptual model, that the objectification of those things. I did an event, I did some typing, then I do an undo. How much am I backing up? I mean, when I do undo, how far do I go back? If I undo again, do I undo the undo, or do I go farther back? Those models of the activity of using the program, independent of the user interface to it, become a critically difficult thing to get a hold of and make clear, but it's critical to the user because they're going to have to know that when they are using the program. So it's not just the objects, it's the use of those objects objectified and how you deal with them. All of the issues of dealing with trouble, of getting into trouble, detecting what the trouble was, being able to get back, make the corrections and get back out of it. Again, take the activity of the program as object. I just did that, here are the events, I have to take those out. Those are, again, things that you need to think through. What are the devices going to make that visible to you? How will the user know that there was trouble? How do you then back out of it?
There's a question about that, because to say it overly simply, successful operation in the normal mode is in the domain of user tasks. Trouble is in the domain of the way the machine works. So when you have a breakdown, because a network is doing something weird, you all of a sudden have to surface things about how networks are organized. You can't just say networking should never be visible because that's not part of the user's task.
Well, there are a whole class of breakdowns which has to do with mechanism coming up and becoming something that you have to be aware of, exactly, to your earlier question. But there are many, many other problems of breakdowns in which I made a mistake, or I'm not understanding it properly, and I think something's wrong. I can't figure out what's going on. And so that's very much in the conceptual model itself. And so, again, coming back to the question of how much do you want to let implementation become part of the conceptual model, I think we do have to deal with those things. If some of those things, the thumbs come in, you just like to try to keep those as much out of the way as you can. I mean, that's a matter of doing a better job of the implementation, but as you say, you can't be perfect. But the ones that I find sort of more telling are the ones which are helping the user when they're making mistakes, when they're changing their direction while they're going on. When they get into trouble, how the heck do you get out of it? We saw that all the time with copiers. And then macros are just another way of again, the objectification and the need to be objective about the activity operating, so that the operations themselves are become objects in the thinking of the conceptual model. And then finally, a whole collection of things, which is one of my favorite subjects, which has to do with how the programs grow, how the applications grow. Do we anticipate in the conceptual model, in what we imagine users doing, them growing the program? And what about situations in which we don't anticipate it, in which they are going to do things? Do we anticipate that we won't be able to anticipate what they're going to be doing? And so do we provide them ways for building their own behavior around our application? The classic margins on your forms, on paper forms, are the situations where you've institutionalized the activity, the place where all the stuff that doesn't fit within the conceptual model of the application. And so it's not that the application is just the thing you built, but rather it is a hook for your activity as a whole. Now, to the extent that you can make those two things align, that the task and the conceptual model are aligned, you probably don't need that. But to the extent that the task is growing and shifting and you're in fact extending what you want to do you, in building your conceptual model, take into account the fact that the user is going to be doing other stuff, putting on post-its, writing in the margins? What are the things that users do? And then are you going to support that as part of your conceptual model of how the application gets used? And again, we sort of cast these as advanced classes. These last two sets, the objectification of operation and then the support for evolution, as things which you don't have to do for many applications. But they're very nice to have, and my guess is that our expectation for those will grow as we figure out better ways of doing these things. Again, I want the conceptual model really clear, and then we can figure out how to put a user interface on top of it. Just a quick glimpse at sort of how you go about building conceptual models. It's just the obvious thing. It's kind of what Jeff said earlier. Pick out an issue, then identify some user tasks which exemplify that issue. Tell the stories about how it could go one way or how it could go another. Then ask, what are the user's needs in dealing with that problem? And then you say, here's my conceptual, how do I build my conceptual model so it supports those needs? And then retell the story in terms of the conceptual model that you have built. So for instance, to the example that Jeff gave just a moment ago, I'm editing. Am I editing on a copy or am I editing the real thing? Okay, examples. In Microsoft Office, typically I'm operating on a copy, and then you do save, right? Whereas in the preferences in OS X, as you start doing it, you're doing the real thing. So what are the user's needs? Well, you got to need to know which model it is. And then you have to be able to say, in one case, if the thing got changed, if I'm working on the real thing, how do I back out of it? Or, in the case where you're working on a copy, how do I save it? At which point does it get saved? And as we know, you get auto-saving going on in the background. You're often in a state of not knowing whether it's changed or not changed. Case of really interesting mechanisms have been brought to bear, the conceptual model of which is not clean. And consequently, it's very difficult for users. So you get this thing. Obviously, here's the conceptual model. I need to know whether or not it's one way. You have objects that are being edited. They get changed. And then the question of, as I mentioned, progressive saving. What's that about? Where does that take? And then now we can go back and say, in using that model, what's it look like here and what's it look like there?
That's very nicely solved in macOS Lion and even better in Mountain Lion.
Good. I mean, so the fact that we have clean models for those things is great, and so we need to get that consistently through. So Jeff was talking about when everything's shared. The photo albums are a great case. If I understand it right, and maybe I don't have the conceptual models right, in iPhoto, what happens is if I put the same photo in multiple albums, and then I modify the photo, I've modified it for all the albums, right? Whereas in Aperture, that's not the case. That in fact, once you put it in an album, then it's an element in the album. I'm not an Aperture user, so I don't know whether that's really true. Yeah.
Maybe it seems like in this example and in the last that the user needs you're talking about a phrase in terms of UI concepts rather than the task that they're trying to accomplish. I mean, is saving a file really something which I would think about when I'm just trying to create a document, or is that something which...
The previous one or this one?
So in this case, that we have all these albums, and my photos are organized into albums. and
Right. So the conceptual models, you have photos and you have albums. And then you have the operations which allow you to put photos in albums. And now what happens if I take the same photo and put it in 2 albums? Is it the same photo or is it copies of the photo?
Right.
Could go either way, right?
Yeah.
That's all. I didn't say how, I didn't say what the user interface
No, I
is
think
doing
he was
that.
just saying that the whole notion of photos and albums, that's a user interface concept.
Oh, that's all right, so back to the...
Okay, maybe, yeah.
No, that, to me, that might be a metaphor that's bringing in, but the conceptual model of the thing has, of the interplay is that I have 2 different kinds of objects I think, in my application. And they have the photos and you have some way of collecting them. Aggregations, calling it an album, maybe you're right, I'm appealing to a metaphor, but and I wasn't really trying to point at the question of whether the way it's shown as an album, that would be a user interface thing, but rather the conceptual structure between that single photo in 2 different places. So again, you can just walk through this example. This is one which occurs again and again all over the place. When you get a new application, you want to find out the question of, again, at the level of making the conceptual model explicit and the operation explicit, the question is, how do you know? Well, you run experiments. Okay, yes, that'll do it. If you think you ran the experiments right, and if you're a good scientist, but most of us, maybe we could do a better job than that.
And if you think to ask the question.
Bingo. All right, so maybe there's a way in which you can regard the book as a whole collection of questions for us designers, of saying, if you're doing this, you might ask yourself about this. And that's what we've sort of tried to lay out. I was going to just talk about dealing with trouble, and this was just how much of undo are you actually undoing? And it's a really interesting case because I don't think most of us have any explicit notion of how much undoing I do when I'm typing. What's the point of the breaks? What's regarded that? I know I don't have a good model of that. I'm not sure whether it's needed because it's a small thing, but I'll type something and I'll type too much, and then I'll say, oh no, let's just back up a character, only I back up 2 lines. It really is annoying. But I don't know the idea of how would you make that visible to the user, I think would be an interesting question. That's a user interface question, but before that it's a conceptual model question. That you have to, if you wanted to support users to know how much was the piece that was going to get done with the undo, that you might want to figure out some way of delivering that to the user. So, yes, Terry.
So a wider example of that is, in many systems that I've used, if you type something and then resize the window and then type undo, the resizing the window isn't part of what it knows about. It just goes back and assumes it was the thing before that.
Yep.
Right. It's compartmentalizing in terms of, right.
So do you regard the resizing of the window as part of changing the nature of typing? Or do you regard it as continuing? Yeah, you've changed, And so you could make the decision either way.
Right, but this gets into a big question, depending on the kind of thing you're building. If you're building a turnkey system for somebody doing banking or whatever,
Yeah.
you have a lot of control. If you're building an app which is going to run in a browser, in Windows, in environment with other applications and so on, a whole bunch of these things are outside of your control, but the user doesn't know it. I mean, I work with my wife, who's very smart, but not computer savvy.
Yeah.
And she'll say, Word just did such and such. And I'll say, no, that wasn't Word.
That was the mobile. Thank you, Terry.
Or this website just did such and such. No, it wasn't. Or the other way around. She'll say the browser did. No, it's the website, right?
Yeah.
And it's very different trying to follow your rules here when you're designing in this kind of tangled ecology of systems.
That's right. And so I think that this really, I mean, I'm not saying that, I would agree with you entirely. The question of what do we need to surface in building the ecologies such that they play well together, I think those are lovely research problems. I mean, we've got lots of experience with it, but what is the level that will allow us to make those pieces fit well together so that you can surf it, and so it looks like you can, so that you as a person building an application can in fact have it under your control at a level which allows you to protect your user from it. I think there's some really hard research problems in there.
Okay, so I'll finish up and then we can take some questions, some more questions if there are any. Are there any questions at the moment? No, I don't see any hands. All right. So developing a conceptual model before you start designing a user interface has several benefits, and I'll try to run through them here. We touched on all of them, but this is sort of a summary of them. One is that I regard when I develop a conceptual model for a client, or when actually I and the client together develop a conceptual model, that's the actual more usual situation. Once we have a conceptual model, we regard the conceptual model as kind of a contract. The conceptual model declares what will be exposed to users, and anything that's not in it is not exposed to users. Should not be ever exposed to users. Okay? And that doesn't mean that the conceptual model design, the document we create, if we do it as a document, sometimes we do it in a spreadsheet, sometimes we do it in a Word document, and actually one of the holes in our book is exactly how you represent these things. I mean, we have some ways of representing them, but more research needs to be done on that. But once you've created your conceptual model and the team has agreed on it, it shouldn't be regarded as carved in stone and never to change, because as you proceed with the development of your application and as you proceed with your user research, you'll discover new concepts that need to be modeled. You'll discover concepts that you thought needed to be separate that should be merged together. You'll discover better names for certain concepts than the ones that you created, and so your model will evolve over time, and that's to be expected. So, but while you have a model, basically people are implementing user interfaces, designing user interfaces, and implementing functionality against that model. The rule should be what is not in the model is not exposed to users. A conceptual model also is, I found, very useful to the user interface designers because it gives them a clear target for user interface design. They're not spinning their wheels creating wireframes for all sorts of things that are not basically conceived of in the model. The conceptual model shows you your object relationships, and it allows simplification. Another thing it will do is it's the basis, as we said earlier, for the product vocabulary. So once you have your conceptual model, you can decide whether the names that you've come up with in your team for calling each of the concepts and all of the actions you can do on those concepts are the ones that you want to expose to the customers. Maybe you want to change the name before you expose it to customers of certain concepts. It's the basis for what I call these high-level task scenarios, so you can write these little stories or little plays or little vignettes of people using the application at a high conceptual level. And those scenarios are actually quite useful in usability testing because they describe what you want people to do without telling them how to do it. Right? So you can give people those scenarios and say, follow this scenario. Open a new bank account without telling them what the steps are in the application for opening a new bank account. Having a conceptual model facilitates documentation, training, and support because it gives the document writers a way of understanding the application quickly without having to sit down and interview programmers to figure out exactly how everything works. And then the best, I think one of the best advantages of doing a conceptual model is that it's the basis for the internal object model. It's not necessarily the only thing that, so basically once you've created the objects, actions, and attributes and the relationships between those objects in your model, then you can just tell the programmers to code it, even before you have a user interface design. You know there are going to be accounts. You know there are going to be a subtype of account called a checking account. You know there's going to be a savings account and a CD account. You can have them code that up without having to know what it's going to look like on the screen. Okay? And that's actually quite advantageous, especially when you're dealing with management, who, when they hear that you want to develop a conceptual model at the beginning, they go, how long is that going to take? You say that developing a conceptual model is going to take 2 weeks? We don't have that much time. We need to start coding tomorrow. So you can actually, the nice thing is that you can develop your conceptual model and they can start coding, and then the user interface designers can start designing based on the conceptual model. So it saves time and money. Doing a conceptual model actually saves time and money in the long run.
Stay around. And so the pitch here is the same diagram we gave earlier, that in order to achieve those benefits, you have to put in place a development process which reflects the need and to have a conceptual model and to work to it. So you want to have the conceptual model early. You need to have...
Then you put it in the center.
Then you put it in the center.
Well, communicates through
that's
it.
self-serving, but I think in fact it serves as a tremendously useful way of getting a lot of the pressures about the application brought to the same place. You need to give everybody a seat at the table. So very often the users have no seat at the table. They may get represented, if you're lucky, by the UI folks, but get everybody to have a seat at the table. Then you need to coordinate the discussion so that if a change, as I said earlier, is brought in because there's a difficulty in implementation, you have to look through, well, what's the cost of doing that? Or if someone's saying, we can't document it because we can't figure out the way of explaining it, that's telling you something, and it may in fact affect everything, against which you can then test. And all of this is in a continuous, ongoing, iterative practice of building it, because as long as you're shipping the product, it's going to be growing. And so this whole collection of a place at the table and everybody talking around the conceptual model is something that needs to be supported ongoing in your development practice.
Yeah, and I'll point out that not only is the whole diagram cyclical, but it's cyclical in each of its parts, because when you get to each of these steps, you can actually do some testing and rotate back. So for example, when I consult with companies that have agile development processes, they'll often say, well, we don't do upfront design, I'm sorry. We just design as we go along. I say, that's fine. We will develop, but we do have to have a place to start. So we start developing a conceptual model, and then we start sort of iterating pieces of it and putting those pieces in the middle, and people start working against those and developing user interface design. So for example, you can develop your model of some of the objects, but not necessarily all of them. And people can then start thinking about what the user interface for some of those objects would be. And then you can start getting feedback and you can loop through. But the important thing is that the conceptual model is going to be the sort of the thing against which all of these other pieces are going to be evaluated.
So these are the references Jeff talked about. Some of these things, and they're obviously, there's a long literature of conceptual models and things like conceptual models, often given different names, which is one of the difficulties, so that it's not like this is, in many ways, There's nothing new here. This is just part of the tradition that we all swim in. It's just that it's not getting, in our experience, honored in practice in a way which I think in the end will save companies a lot of money and save users a lot of headaches.
So, questions?
Kind of like this last point, isn't the piece missing that would link this conceptual work to the actual tools that people use? Because people deal up with, if you're lucky, Swing, if you're not lucky, jQuery, or whatever. And there's a large disconnect between the concepts there and what you're talking about. So why, even though this notion of conceptual model has been around for 10 years, we don't have sort of a tool set that embeds some of these things, especially for things we solve again and again, like sharing examples or the undo or all these things.
Yeah.
Billy is charged. The only thing I would say is that when I did Trillium a long time ago, the attempt was to give the designers the opportunity to design the concepts out of which they were going to design. That was entirely in the UI area. But building the concepts into the tools, I think, is critical. It's not like you can build them in to start, I think. It's what happens is in the process of doing your development, they need to get expressed within the tools. But the fact that the tool will take it on and allow you to then have that as leverage seems to me right on.
So let me just ask, do you mean tools for developing, designing conceptual models, or do you mean tools for building applications that embody some of the things that we talked about?
The second,
Okay.
which to me is
So,
was the
for
first
example, one of the things that I often wondered about is why does everyone who builds an e-commerce website have to build their own shopping system? Why isn't there just a shopping cart widget that I can sort of pull in from HTML, right? It seems like the browser should know what a shopping cart is. I shouldn't have to build one in my website.
Well,
Wendy?
that's a long conversation.
Okay.
But I want to just make a different point, which is you said later on in the talk about giving everybody a seat at the table and bringing in users. And I know you really believe in that, and I'm sort of a stick with participatory design and getting users in from the very beginning throughout. I think one of the reasons why it's difficult to work with end users, if you want to use that term, is that the ways that you express conceptual models when you're talking to a programmer may not be at all the same way that you express them to an end user, and the HCI designer may or may not be able to make some sort of transition. And so I just wanted to hear what you have to say about that. Like, how do you actively get users? I mean, I have my own opinions on that, but I'm sure you do as well. So how do you let them sort of interact with these conceptual models in a useful way for them, as well as for the designer?
The table, as I imagine it, has got lots of different languages around it. And part of the business of working collaboratively with other people is learning their language, learning how it looks to them. Expecting users to understand how it looks to the coders, I think, is probably way too hard. So the question of maybe, I don't have any easy answers, but the bridging it into that by having people who are hearing what's going on, letting the user, my favorite is let the users tell you back through the application itself. And then, because the moment of real squeak is the moment of use. And I'm lost. I can't figure it out. Give me a way to yell at you in the middle of the situation.
Okay, so our time is officially up, but you can come up and ask questions, and thank you very much.
For more, please visit us at stanford.edu.